And get us started pretty soon to give our speaker today more time total. Now, you see before you a Cornell graduate from about a dozen or 15 years ago who took the energy seminar and made the mistake of remembering me and calling me up and saying, why don't you come down and give a talk at my company? And I said, well, that would be hard for me to do during the semester because I teach so many days of the week. But why don't you come and give a talk at Cornell in the energy seminar? So we have today's speaker, Tamar Sharabi from Philadelphia Gas Works. And I would like to point out for all of you who are activists, and I hope that's virtually all of you who are in the audience today, she was the president of the Society of Sustainable Engineers when she was here at Cornell. And so I asked her if it was okay if I introduced her by asking the question, can you be happy working for Philadelphia Gas Works when you started out as a sustainable engineer at Cornell? And Tamar, I hope you enjoy answering this question.
I'll make a small correction. The group was called Engineers for a Sustainable World.
Okay.
And I'm making that distinction, and I'm smiling as I'm talking to you all, because first of all, I really remember being one of you and having wonderful speakers come to the class and share different perspectives from across the industry. You know, and I reached out because part of it was that I think we need it all. And having, you know, I got my first job being a student in this room, was in a different room at the time, and having a passionate speaker that at the time worked for...
I'm gonna mic you.
Ooh.
When we find a battery that works, this
Okay.
is one of our basic problems.
Okay, I'll project more. So what I was saying is that one of the speakers at the time...
Here we go. Okay,
Thank you.
thank you so much. It came on green finally.
Is this better?
Yeah.
Oh, yeah.
Yeah?
Right.
Okay. So as I was a student, one of the speakers at the time was someone whose name was Art Weaver, who worked or actually founded a company called Renovus Energy that was putting solar panels across homes in Ithaca and businesses and etc. And I was very inspired, and I said, hey, you know, in a follow-up email, thank you for coming, and I'm interested in working with you. So that was my first job. And the trajectory from working for a solar company to years later working at Philadelphia Gas Works, to me makes a lot of sense because it's still filling the energy needs that we have today, right? We need the renewables, and we also need what is available today and what is the infrastructure that we have today. And we should constantly be dreaming big about how we can progress the environment, our people, how we can do things better for all of us, right? The answer is not one solution. Anybody that works in energy, anybody that's researching energy knows that it's a complex question. So I hope that was a good answer to start us off. And I'll be talking about that as I go on. And actually, the first thing that I'm starting with is actually just a picture of our website, because what I want to draw your attention to is LIHEAP is now open. As we talk about our energy needs, LIHEAP stands for Low Income Home Energy grants that are available from the federal government so that people can help pay their energy bill. So actually, I want to first start and ask, who here is paying an electric or gas bill? And who enjoys paying those bills? Nobody might enjoy paying those bills, right? But they're a part of how we're getting our energy, and they're a necessity. And Philadelphia is is actually the poorest big city on the east in the country, right? So I want you to take that into consideration. I know that when you're a student at Cornell, everything is abundant and feels that you know, we have wonderful resources and labs and amazing faculty here, but that's not the situation for everybody, right? It's 26% poverty rate in Philadelphia, and that has a big impact on our energy landscape. And I'm putting this up here, our mission and our vision of our company. So we want to provide a pathway to a thriving and cleaner future through innovative energy solutions. So that's broad, and that's part of the vision that we have at Philadelphia Gas Works. So this is the city, as I touched on. It's a beautiful city. Who's from Philadelphia? Anybody? Okay, one person. Would you call it a beautiful city?
I would say this part is a beautiful city.
So the sixth largest city and our population density I put up there, it's about double what Ithaca, New York is, and less than half what New York City as a whole is. And what that means for us is that when we're doing projects across the city, we have a lot of different people and a lot of different institutions that we have to deal with. Anyone want to guess how many years Philadelphia Gas Works has been around?
250.
Okay, that's a lot. 184 years, I think we just celebrated that anniversary. So 184 years is a long time, and our country has changed a lot in that 184 years. This is Market Street Works, when Philadelphia had a few different companies around the city that then became a part of Philadelphia Gas Works. And actually the structure is no longer here, but this was one of the plants at the time. Pretty old picture, right? But that's how some of our business operations happened back in the day. So just some basics about the company. We have about 500,000 customers, 3,000 miles of main and 3,000 miles of services, that's underground, and about 134 square miles. In comparison, Ithaca, I think, is 6 square miles. So this is the area of the company that I work in. I've moved around a little bit, but I'm in field services. And the company as a whole has 1,600 employees, so it's a pretty big company. And it's very exciting because there's a lot of people that are professionals in different areas, and you get to learn a lot across different departments. Operations and supply chain, as you could see, between resource management, financial, GIS, process improvements, all the way to the other side, you have to deal with the materials, right? And right in the middle, and I'm putting these numbers up because the bulk of our capital spending and operating costs are right here, right? We're doing the work to make sure that what's in the ground stays safe, and we're also doing the work to make sure that everyone is getting the energy needs that they have. Are any of these familiar to you? They should be, right? Hopefully. So somebody want to guess what some of these acronyms are? Hopefully you know. Go ahead.
FERC is the Federal Energy Regulatory Commission.
Okay, very good. Anyone else? Hopefully you know.
PUC is Public Utility Commission.
Uh-huh. That's the one for Pennsylvania. So hopefully you know the EPA. These are just some of the regulating bodies, right?
Yeah, the former EPA.
Now, what I would like to say is that we are a municipally owned gas utility, and that's a very special place to be. We're actually the largest municipally owned gas utility in the country, and what that means is that we're responsible not just to our ratepayers primarily, right? But we have to be responsible and make sure that the CEO, he's actually reporting directly to all of these bodies, but most directly to the city council, to the mayor. They're on top of us, and they're making sure that we're not just in compliance, but more than that, that the rates that are set for the public, all of these bodies have a part in that, right? So I put a snapshot here of the Electronic Code of Federal Regulations because we're not just regulated on the city level, as I just mentioned, but also on the state level and federal. Here's the Pennsylvania Public Utility Commission. And gas associations. Now these are bodies that support us in our operations, but in a broader sense, I've gone to some conferences where I've received really important training. It's also an opportunity to talk to people that are in other utilities across the country. And hey, what's going on in your department, and how are things changing, and what is the public saying, and how can we do our operations better? So it's not just in terms of what's happening inside the utilities locally, right? We have to be looking at a broad perspective across the country. So you've probably seen these type of charts before, hopefully in your other energy classes. I put this to just give a broader perspective, right? Where is gas production happening? This is from the Energy Information Administration. And I'm going to contrast that with the next one for shale gas. And as you could see, a lot of the shale gas is in the area of where we are. And this is, again, a broad perspective of how much trillion cubic feet of natural gas resources that we have at this time. Now, I brought this up as well because Pennsylvania is at 20% in terms of the top 5 natural gas producing states. This is important because I'm sure when you're evaluating engineering projects, what is something that comes up? Economics, right? We have to make sure that the projects that we're designing actually make sense and that we can pay for them. Now, granted, we're in a different environment in Pennsylvania than we are in California, than we are in Texas, right? Things cost differently because things move differently, and the resources that we have locally are in a different picture in a different state. And I wanted to also start this presentation in a way with the bigger picture as well, in terms of on the left, right, you can see the percentage of natural gas that's our primary energy consumption. And this is 2018. That number used to be much smaller. And as we think about what kind of fossil fuels we want to be displacing, we do think about coal, we think about oil. What is the cleanest burning, and what does the future look like? How can we get there? So I think this is kind of gives you some perspective that only 4% of residential natural gas consumption, that's the entire pie of the greenhouse gases from all other sectors, right? So that's only residential, but it's still an important when you want to think about what's your footprint and how does it relate. And when we look at the entire sector, you can see as well, you know, where can we make the biggest changes so that we can see that long term.
I'll come back to that one later.
Okay. So interstate and intrastate pipelines, this is what it looks like underneath our ground, right? It's pretty busy down there. 2.6 million miles of natural gas pipelines. So I'm not going to focus on this side of it, but this is where it's all coming from, and hopefully you're learning about some of those things. Philadelphia Gas Works is this side of it, right? We're the distribution company. So what does our distribution system look like? On the left-hand side, you can see a pretty nice, I think, chart. All of the black that you see, that's cast iron, okay? We have different pressures across the city, and as you can imagine, it's a balance, right? We have to make sure that we're able to provide the right amount of pressure to every customer, right? Your appliances are rated for a certain number of inches water column, or if you want high pressure. So this is something that we have an entire department that's making sure that we're providing a safe pressure in our system. And this is another photo of beautiful streets in Philadelphia and some of the challenges that we have. Some of them are cobblestone, we have trolleys, we have congested small streets. And sometimes that's what it looks like. And I'm sure for the homeowners or even renters, you know, you don't really want this going on in front of your home, right? It's not too exciting. So we try to provide the best service, the safest service, and as efficiently as possible. So here are some of the materials that are underneath the ground. I mentioned one of them. Anybody have any other ideas of some of the pipes? Materials, people?
PVC,
So plastic, steel, cast iron, and ductile iron. That's what's currently underground. So as I mentioned before, aging infrastructure, 43% of our mains are cast iron. I'm going to get into our main replacement program and how that ties into it. And because we're such an old, been around for 180 years, right? Over here, all of the yellow, that's between the 40s and the 50s. The green is what's new, which you can barely see in there. But all of the red, we have some pipes that are over 100 years old that are underground. PHMSA, Pipeline and Hazardous Material Safety Administration. So they actually mandate, right? That's through the Department of Transportation, that we have a distribution integrity management program. So that's knowing what your system is, identifying what are the threats, and then evaluating and ranking the risks. So that informs part of our process in terms of how we go about creating projects around the city. I didn't mention that right now, so I work in planning. So in that department, we have everybody that was working on literally the plans of the street, right? I know some of you have to take an AutoCAD class here or a CAD class. Sometimes we're looking at our maps of our streets, of what's underground, what's in the system. So DIMP, as I just mentioned, we have a long-term infrastructure improvement program that leads to our main replacement. We also have accelerated actions and a survey program that I'll talk about. But why this is important is because every year we have a baseline goal of how much main we have to be replacing. And that leads us to our main replacement prioritization. So in this chart, what you could see is that basically the red is what the programming, so we have people that work in GIS, we have people that are working to geocode where have the prior leaks happened in the city so that we can prioritize to make sure that that's the first place that we're going to be replacing the infrastructure. So the process is geocoding where the leaks are, running risk analysis on them, and then putting some different scenarios, right? I told you we are living in a congested city, so we have also the water department to deal with. We have to be thinking about the streets department. We have to be thinking about PECO, our electric, right? There's Verizon, there's other institutions, companies in the city that also have different projects going on, right? So how do we work with them to make sure that everything is happening as efficiently as possible for our public? So this is just an example of what it looks like underneath the streets. The white and black and also the yellow and black, that's what the programming will select for us and say, you know, this is this number on the list of what needs to be changed in the system. And so us as engineers then go in there and say, okay, does this make sense? And how can I combine this with another part? Or what's also happening environmentally, right? A couple of years ago, the Pope came to Philadelphia, right? We have other big considerations to make sure that there's not work happening when there's other things happening in the city that we have to be aware of. In the planning department, we have drafters, estimators, people that work on permitting. You can imagine that it's not just the city permits. You know, this is an example, Frankfurt Avenue. You know, if we have a street that also happens to be a state highway, we have to do the proper permitting for that as well. And those things take time, right? So I just wanted to here show you when we install a new main, what does that look like actually for our customers, right? Because if you're in the middle of winter or if you're just coming home from dinner, from work one day, you don't want to have interruption of your service, right? You want to make sure that your boilers has the necessary energy and you can cook. So we're going to tie in to the new main, and then we switch over. And what's important is the new main and the old main will be energized at the same time until we make the switch. And I'm just giving you a depiction of that. And then the final tie-in will happen. So most of our grid, right, there's rules also as far as what the pipes, when we go underneath the ground, what they look like. We have to make sure that they're perpendicular, our services. Sometimes there's exceptions. We also have a steam loop in Philadelphia that we have to be aware of. We also have trolley tracks in Philadelphia that we have to work around. So underneath the ground is pretty busy. We do our best to let our customers know that we're going to be working in their area. What that looks like is on our website, some maps, letting them know where we're doing work at the right time. And this is a pretty busy part of the city. This is, right downtown, and as you could see, we have a lot of people on site. Sometimes, we need to use police to make sure that the street would be blocked off the right way. Sometimes we work with contractors as well. I mentioned we're a 1,600 employee company. Of that number, we have a union that is doing the work on the street, right? Those are the people that are going into your homes. Those are the people that are literally digging up the street. So distribution work. I wanted to show this because, 180 years, things have changed a lot. Yes, we still need to be digging by hand, but we also have sometimes available to us is a vac truck. So there's just some numbers, and they're, rough numbers. That's 2.5 to 13 cubic yards an hour that we can productivity, as compared to less than a cubic yard per hour for hand digging, right? So all of these things are important because as engineers, we're also approving estimates of how much things cost, right? So I need to know for this concrete in this area or in another area, how much time is that going to take? How much of the ground do I have to open up? Those are all part of it. And here's another photo that I put on the left. We have contractors that are working with us. On the right would be a typical, I think 3 or 4 inch plastic main replacement. So in this photo as well, you can see the new main, you can see the old main, and we have to cap and put that out of service, right? So this is sort of our numbers of how much cast iron we've been removing through the years. Who knows what happened in 2009? Financial crisis, right? It affected all industries, including our own. So we also have accelerated progress. So, 1 year, if we're mandated or we're putting a goal of replacing 18 miles of main, we're always trying to beat our goal. And how can we be more efficient? So there's actually a number for how much greenhouse gases we've been able to reduce just through our main replacement, right? As a company, we're conscious of many different areas where we have to make improvements, but also just in the infrastructure itself. As we do main replacement, cast iron can leak, so can plastic, right? But we want to make sure that the materials that we're using are the best available, that we're able to reduce any potential for leak, right? Now with the climate getting really cold and then really warm on a day-to-day basis, those shifts, those have serious implications for our pipes, right? We're not used to the climate that used to be and what's might be approaching, right? So we have to be considerate of that. And then I mentioned surveying. So this is actually coming from state laws as well, federal laws, excuse me, to make sure that we're also always surveying our system to look for potential leaks. So This car on the right-hand side, it actually has some of the equipment that's doing the surveying across the city. We have crews that go out, that do walking survey, that do driving survey. And then I wanted to show you some data because as a data-driven company, always bringing in new information, we also are looking at how many, what did things look like before and what are things going to look like in the future. On the right-hand side, 2021, 2022, how many field service orders, how many technicians do we need? I'm in management, so what that means is that I need to make sure that we have the right amount of people in the right part doing the right jobs, right? Sometimes that changes throughout the year, right? In the wintertime, we might need more people to respond to leaks. Other times of the year, we might have more people working on new business. This is kind of a chart showing you every season the number of work orders that kind of fluctuate as the year goes on. And odor complaints, right? It could be from appliance leaking, it could be from a street leak, foreign odors up there because sometimes there might be industry in your neighborhood or in your area and people think, okay, let's just call the gas company because it might be them. And sometimes it doesn't have anything to do with our infrastructure, but we have to respond to it. We work very closely with the fire department to make sure that we respond appropriately. And these are other areas of the company, making sure on time. So network analysis, you can imagine as we get more customers or if customers go offline, we have to make sure that we have the proper pressure in different parts of the city. We have pressure recording equipment all around the city, making sure that things are the right pressure. We have, those are just photos of some regulators, as I mentioned. The majority of our system is low pressure, but we also have some high pressure main, and we have to make sure that that's regulated to the right pressure. And SCADA, that's system control, analysis, data acquisition, right? It's constantly making sure that we're at the right place. When I first started at PGW, I actually worked in the meter shop, so I got some hands-on experience with our meters and our equipment that's in the field. Meters are important to gas companies because they're registering how much gas you're using, and how much gas you use is how much you're going to get billed, so they're very important pieces of the equation. Anyone know any of the names of the kind of gas meters up here? So all the way on the left is a diaphragm meter, in the middle is a rotary meter, and on the right is a turbine meter. So there's different uses. You might be most familiar with the one all the way on the left because that's the most common that's used in residential. Rotary would be for more consumption, more volume, different pressures as well. And I asked because I remember I took a class here where we built an air motor, and it looked very similar to a rotary gas meter. So the future, right now, how do we get the data from the meters of how much gas you're using, right? In the past, you had an entire crew of people that would go into people's homes and actually read your gas meter. Does anyone remember that? There's still places where that's done, and that makes sense. AMR on the left, automated meter reading, that is a picture of an electronic device that was on, the transition at PGW happened in the early 90s, and we had to go into all the homes, 500,000 homes, and put a device on the meters so that a car could drive by. It's a little radio that wakes up and gets the data of how much your use was for the month, right? For some customers, it might be that they need that on a daily basis. Those are a different set of customers, but you might be familiar with gas choice or being able to choose where you buy your natural gas or electric from. So then there's a whole other set of rules about that and reporting and knowing what your consumption is on a daily basis, which might be different than for other customers. On the right, AMI, this was a big project that was one of my big projects working at PGW in the last couple of years. So that stands for Advanced Metering Infrastructure. And so you can imagine that you have a fleet of cars and people that go driving around the city to get what your reads are on a monthly basis, right? What if we had a fixed network that was able to get that information? So that's where the industry is going. Some places it's been around now for more than 10 years in California and other places. This is something still in the pipeline in Philadelphia Gas Works. And I have here a schematic of our gas plant at Passyunk. I wanted to show that our company is not just field operations, although that's where I work, but we have gas supply, gas control, and we have our plants as well. So this is a schematic of Passyunk plant. And then we also have 2 LNG plants, LNG tanks at Richmond. Does anyone know what LNG stands for? Liquefied natural gas. So that's what the plants look like more or less today.
Is that Richmond, Virginia, or in Philadelphia?
Richmond, Philadelphia. So it's just the name of the local plants. There's an entire environmental services, chemical services part of our company, right? I mentioned earlier the EPA. The EPA has only been around since around the 70s, right? So our gas company has been around since a lot longer than that. And now that the EPA is around, we have to make sure that we're doing all of our operations per regulation. We have a fleet of CNG vehicles. Only a small portion of our fleet is CNG, but we have our trucks that you saw earlier as well, all of the operations to respond to leaks, all of the construction crews have trucks. This is another area that we're using so that we can promote the use of natural gas as alternative fuel. Micro CHP, Cornell has CHP, right? Is everyone familiar with what that stands for? Yes. So you know that when you make your own electric locally, that's much more efficient. And since you're making, since you want the energy for your, for example, what would be the reason that you would want to do it? It's efficiencies, right? The electric grid, we can have another conversation. I'm sure you've had seminars about that as well, of how much you're losing just in the electric grid distribution. I mentioned about the main replacement and how that is supporting reducing our emissions just in terms of our main replacement, but we're doing our part not just in that area. There's always savings that we can do and efficiencies that we do as a company in many other areas as well. So I wanted to let you know we're also working on that. And looking into the future, this is a slide from some images from the American Gas Association. I had a conversation earlier today about some of these topics. RNG is renewable natural gas. Hydrogen blending, I think, is a really exciting area. I hope that people are discussing that here at Cornell. It's very exciting, you know, I mean, where we were years ago to where we are today and where we will be in the future, we don't know exactly, but those are part of what the future might look. And we're always recruiting smart and bright engineers. I hope that you can keep a really broad perspective of what our energy landscape looks like in the country. It's very exciting to be on cutting edge of what the next fuel cell might look like, or what our alternative vehicles might look like, and the field is very vast. I never imagined that I would be working at a natural gas utility. I'm very proud of it. I think as a municipal utility, we have to be responsible not just to our shareholders. We don't have shareholders. Actually, PGW is a nonprofit. It's more difficult to think about that in terms of the scale and maybe what you're more familiar with smaller nonprofits. But any of the money that is recuperated from our charging customers for their energy use on a monthly basis, that gets back into the system to make sure that we're keeping the system safe and moving forward. So now I hope we can go into a discussion. I'm sure that there's some questions. I'd love to hear them. I hope I can answer them. I do want to say I'm very honored that an old professor of mine is in the room as well, other than Professor Hammer. So, you know, it's very exciting to be back here. And, you know, as a student, sometimes we're inspired because of different reasons, and there's really so many ways that your education here at Cornell could take you. I encourage you to continue dreaming as you're a student here, but also make sure you speak with some of the professors that have been here for, you know, what is economical, what is realistic, what is based in what our systems actually look like, and how can we push them to be more efficient? How can we push them to be what's better, not just for us here, not just for what's good for Cornell or the state or the country, right? We're a part of a global system. I think that my time here helped me see that, and it's something that I continue to learn. So with that, thank you very much for having me. It was a pleasure to be here, and I hope we can have some discussion.
Thank you. Tamar has left time for questions, so who would like to start?
What's the difference between LNG and CNG?
CNG is compressed natural gas, and LNG is liquefied natural gas. So what our gas supply looks like, you can imagine everything has to do with economics, right? So PGW, as I showed the chart, the graph of where all of the pipelines, there's two big pipelines that come into Philadelphia where we're buying our gas from. That gas gets purchased at different points across the pipeline. It's really fascinating, and anyone that's interested in engineering and also finance, I actually encourage them to look more into it. I think it's really an important field. A lot of it's out of our hands, right? Because we're just buying the gas. So that gas is a gas, liquefied natural gas. That's what the two plants that I had pictures of, our Passyunk plant and our Richmond plant, we actually liquefy the gas that we buy so that we can provide energy at a cheaper rate during the peak times. So that's really important for when we have, I think in 2018, we had a polar vortex, really cold temperatures. You can imagine there's lots of people across the whole state that at the same time, they need to up how much gas they're buying. So we have to make sure that we have reserves to meet the needs. Philadelphia, I said, was number 6 in terms of population, 1.5 million people. The liquefied natural gas is to supplement when we're purchasing the gas. So it's an entire, I could give a whole seminar on LNG and how that relates. So CNG is compressed natural gas, so that could be used for vehicles.
Thank you.
What is your company's stance on hydraulic fracking?
On what?
Hydraulic fracking.
Well, I showed the chart earlier. I think it's more than 50% of our gas that's being used is coming from fracked Pennsylvania. You know, that has a big part of how much things cost and in making sure that we're providing the energy that Philadelphia needs, right? So do I have a position about it? Does PGW have a position about it? We buy that gas. So that's to supplement the entire city in terms of their energy needs.
Interested in learning more, sorry. Hydroblend? What do you mean by hydroblend?
Yeah, it's really an exciting area. Hydrogen blending right now, I've read some white papers about it and I've looked into some research about it. I actually have a friend that I used to work with when I worked in solar that is now working for a hydrogen company that's based out of Boston. And what they're doing, it's very exciting. I think the Orlando Utilities Commission had a big grant with the Department of Energy recently that is basically being able to use some renewable electric source to create hydrogen gas. And that hydrogen gas can be supplemented into our infrastructure systems that we have currently. The conversation in the United States, I would say, is a little bit behind what I've seen in Europe. But some of the studies that I've looked at are, in Europe, they're saying up to 15 to 20% of our infrastructure could be, of natural gas, could be supplemented with hydrogen. What I've seen here in the US so far is maybe 5%, right? These are a different kind of gas, so how is that going to affect the properties of the materials that we're using, right? How is that going to affect? So those are all questions that are still being explored, but it's a very exciting future because maybe that means 20% down the line or whatever percentage can be reduced in terms of the emissions reductions from natural gas.
Is it liquid or is it gas? Hydrogen?
Hydrogen gas.
So this is very interesting, thank you. So there's a few questions I have that you could maybe expand on, but then I think both Max and I want to ask you about the amount of gas that's going into heating. Doesn't look like the numbers we've used. But first of all, you've got a very challenging infrastructure. It's old as well as new. What's the thing you showed about greenhouse gas reductions? Was that related to methane leak? Must have something to do with cutting down leaks, which is a pretty good story, right? Because you're not really cutting down on gas consumption by the consumer. It's more the leaks in is that true, or the leaks in distribution system? Because that's a powerful result, right? Mm-hmm. You showed a terrific drop off.
Mm-hmm. Mm-hmm. So the amount of leaks, so the EPA actually assigns a value for what cast iron, so for CO2 equivalent, and it has everything to do with the leaks, right, from cast iron compared to plastic. So as we can convert our system away from cast iron, that's reductions that we can say.
So these are measured, so you kind of know how much gas you purchase, right, because you're buying it. Mm-hmm. You know how much consumers use because you meter it.
Right.
What's the difference between those two? Presumably are leaks, is that right?
So there's actually a report that we have to do every year, and it's called Unaccounted For Gas. Yeah. And the number is very small, on the amount of gas that we're purchasing to feed the needs of Philadelphia to the amount that is actually unaccounted for, it's less than 1 or 2%.
Right. It seems to be getting smaller.
Yeah.
Because you showed that decline.
Mm-hmm.
Okay. If you have enough, we can let other people ask questions.
Let's follow up just from last semester. Last semester we had somebody said that who said that some places were as big as 6%. So I'm glad to hear that your company is at the 1 or 2% level. That's a good thing, just in a relative sense. Yes.
I want to ask you about the steam loop and also about that very small scale combined heat and power. Is that impressive? Household scale? Can you say a little more about those?
They're not promoting, so our marketing department is not promoting micro CHP for small residential. It would be more laundry mats, for example. There's the commercial side of everything, right? And then what makes sense on a small residential, I mean, at the end of the day, this is a small, the majority of our customers are residential, but there's still savings that lots of commercial customers can make with converting to micro CHP. I don't have the numbers in terms of how many have, it's sort of, but I can get that for you if you're interested in that. And then your other question, the steam loop, yeah. So actually, some people get their energy from the steam loop in Philadelphia, and that's coming from another company that it's actually changed its name several times. It was Veolia. There's a new name for it in the last couple of weeks or months. And actually, I was a part of a big project there because they're our biggest customer, actually, because they're buying gas from us to convert it to steam that then is supplying mostly, I can say, University of Pennsylvania, but then also some city buildings within the center city area of Philadelphia. And right, as engineers, we have to think what makes most sense. In some parts of the city, I know, University of Pennsylvania is also a very old institution. They're not gonna make room all of a sudden in their basements for some boilers, right? So there's a reason why they might want to use steam. Mm-hmm.
Yes.
Since you're a publicly owned utility, I was wondering that you didn't talk about sort of improving efficiency standards in households and trying to get people to use less gas. So you spoke of Europe. I come from Europe, from Central Europe, and I'm shocked about the insulation in the house I live in here, and I feel I'm largely heating my surroundings.
Thank you for bringing that up. And I should say I'm sorry that I didn't have a slide that was just on all of the work that we do. We have an entire area of the company that does energy sense, not just what is required, but also above and beyond. I think we have helped retrofit over 19,000 homes within Philadelphia to be doing energy upgrades. So not just, we also have rebates that are specifically for more efficient boilers. There's not just the efficiencies on our end, but it's also obviously on the residential. And I mean, as I shared, 26% poverty rate in Philadelphia, you know, people want to be paying the lowest gas bill that they can, no matter what, right? So, I mean, I agree with you, and our company is doing a lot. I can give you more numbers about that in terms of, yeah.
I was interested in any opinion on the SYNAC study that was done a year ago, 2 years ago, that showed basically that you could go to total biogas as well as with heat pumps and stuff, and actually shrink the service territory of Philadelphia gas works a little bit, where it's not economic. What do you think of the study, and if you've read it?
Tell me, what is it called? Because maybe I didn't hear you.
It's done from a consulting firm out of Cambridge, Mass.
Okay.
SYNAC. They did it for the Conservation Law Foundation, I think. It's more than just Philadelphia. Southeastern Pennsylvania.
I can't.
It really shows that you could go to 100% biogas. Not at an extreme cost.
As of a couple weeks ago, people, so as I mentioned, there's something called gas choice. So I know that you have it in New York as well. You know, you can choose, just because Philadelphia Gas Works is your distribution company and that we own the pipes that are going to carry the gas, you might choose to buy your gas from another cooperative or another company that is getting their gas from a renewable source, right? The questions around if it makes sense economically, where it's coming from, there's more questions there, but I think it's really great. And I think that, to be honest, right now, as of a couple weeks ago as well, there was a company in Pennsylvania that was providing RNG. The cost quoted in the article about it was that it's only going to cost you about 50 cents more, you know, per unit to switch to buying RNG. It's still not enough. I think that we need to be innovative and making sure that we have all, not just from biogas, as you said, heat pumps. I mean, these are all areas that are a part of the energy landscape, and how can not just our utilities, but how can our regulators, how can the public, you know, be advocating for these things. So I'm not familiar with that particular study, but there's many that are, you know, about that.
Okay, well, I think we have put you through quite a few questions, and thank you very much. Someplace out there is the sign-in sheet. Please hold it up if you